Homework sheet U11d question 6. In part A we have an integral that we need to figure out. We want to start by separating this up into two fractions, 9x over x plus 6 over x, individually. These can then be simplified to 9 plus 6 over x with respect to x, and the integration is then straightforward. 9x plus 6 log x plus c, as there are no limits. In part B, we have a differential equation to solve. We need to start by separating the variables. We want to move our y terms over to the left hand side and keep our x terms on the right hand side. This therefore gives us the integral of y to the power of minus a third with respect to y is equal to the integral of 9x plus 6 over x with respect to x. This right hand side is what we've just done in part A, so I can replace that with a 9x plus 6 log x plus c. On the left hand side, if I integrate that, I need to add 1 to the power and divide by the new power, so I get y to the power of 2/3 divided by 2/3, which is the same as timesing by 3 over 2. And I only need to put the constant of integration on one side. I could multiply up by 2/3 to get rid of the constant in front of the y term. 2/3 of 9x is 6x, 2/3 of 6 log x is 4 log x, and 2/3 of c is just another constant, so I'm going to replace that with a different constant, k. And then I was asked to give the answer in the form y squared equals, so if I cube everything, I've got that done. However, I was given initial conditions in this question. When x is equal to 1, y is equal to 8. So if I plug these constants into my equation, I get 64 is equal to 6 plus 4 log 1, which is 0, plus k cubed. So 64 is 6 plus k cubed, therefore k equals negative 2. 4 cubed is 64. So my final answer is y squared equals 6x plus 4 log x minus 2 cubed.